Alright, here's the graph of the information given to us in our table. Notice here I've labeled my horizontal axis with the input variable, years owned, and the vertical axis with the output, thousands of dollars. And so here's a good question. If you were to given this scenario, this represents the value of the vehicle here. Notice it's going down, obviously, for those given years owned. What other point would you be interested in knowing that the value here is going down? If you own this vehicle yourself, this truck, what other point would you be interested in? And hopefully you're thinking, when is this value going to go down to 0? And so that's a good question to ask. So if this, since we have a linear equation or linear function, I'm going to draw a line that best resembles a line. Sorry, I'm trying to do this with one hand. Alright, there's my best drawn line, freehand. So the question is, where does this graph reach a 0 value here? That would be interesting. Just looking at it, it looks like it's 12, the way I've drawn it after 12 years. But using a graph is not always the best way, because you're really just estimating here, especially if you use any kind of ruler or anything, still an estimation. Let's do it numerically. So here's the idea. We're going to find where this graph crosses this axis. And this will give us, after how many years, there's no more value. So let me give you the definition of that point. We call that point right there the horizontal intercept, and it is the location of where the graph of a function crosses the horizontal axis or the input axis. So where our graph of our linear function crosses this axis, that's the horizontal intercept. And we want the location, and the location for us will be given to us as an ordered pair, or should be given as an ordered pair. Okay, here's how we can use our slope and a point on our line. Let's see the last one, 8,6. Remember what we did in our last activities was that if we think of this as over 1, this is the decrease or the change in the output, and this is the change in the input. So as your value decreases, or I should say it this way, your value decreases by 1.5 every time the year increases by 1. So if we increase our year by 1, that should go down by 1.5. So I'll do this mathematically here. We're going to subtract 1.5, that change, to that V value as the T value increases by 1. So we have that arithmetic to do. So the input increases by 1, bumps up to 9. That's going to go down by 1.5, or 4.5. So that's 9, 4.5 is another point on our line, and we keep doing that until we hit 0. So again, subtract negative 1.5 and add 1 here. That'll give us another point. So 10, 3. Alright, keep going until see what you get, and then compare mine in the next video.